Earlier today, or the first half of the morning, is all of these mathematical practices involve rigor because we need to know the why and the how of the mathematical problems that we're trying to solve with our students. So, mathematical practice 2, reason abstractly and quantitatively. And again, that's just going deeper into what the problem is asking for and trying to use those to solve the problem. Mathematical practice 3, construct viable arguments and critique the reasoning of others. Again, when you're working with another student, why did they choose to do it this way? Why did I choose to do it that way? And allow those students to discuss that, which again contains that rigor and coherence portion we talked about this morning. Model with mathematics. This is big in mathematics. We have an instructor at our program, local program, to show, she uses donuts and M&M things to model when you're doing the mathematical practice. So use things that you can, and of course everyone knows the piece and the pie for fractions. So model with mathematics. MP5, use appropriate tools strategically. Where does this fit? What tools can I use to help solve this problem? And in some cases, we know in the GD, you can use a calculator, but you need to use those calculators strategically, not just say I have a calculator to answer all the problems, but I need to use it strategically. There's reason to use it. Math practice 6, attend to precision. Of course, you want to get the correct answer and be as direct as you can. MP7, look for and make use of structure. What is the problem asking for? How is it structured? And MP8, look for and express regularity and repeated reasoning. Again, everything in standards builds on what's happening before and some of your historical knowledge. So MP8 will cover some of that. All right, let's go a little deeper into all the mathematical practices. And mathematical practice 1, as we said, it says make sense of problems and persevere in solving them. So what would the task of the student be? And we would say the student would be looking for different ways to solve a problem, explain using both pictures and words, and they would make connections on the way they solve the problem, how others solve the problem. And that's communicating. And like we said before, that also builds on some ELA standards as well. An example of questions to develop mathematical thinking that the teacher might ask was, what might you change in this problem? Or what are some other strategies you might try? Mathematical practice 2, reason abstractly and quantitatively. Students task, the students would make sense of quantities and their relationship in problem situations. They would recognize those quantities and represent them in different ways. They can use numbers and words to make sense of a problem. And the teacher may ask, what do numbers used in this problem represent? And how did you decide in this task what you needed to use? In mathematical practice 3, construct viable arguments and critique the reasoning of others. The students would justify their solutions, demonstrate active listening, speaking and listening, remember that one? Make statements to prove or disprove concepts, or present ideas. Remember yesterday in ELA we talked about rational arguments or complicated or difficult texts that can prove their arguments. Examples of questions that the teacher may ask is, how did you decide to try that strategy? Or how did you decide what the problem was asking you to find? What was unknown in the problem? And did you try a method that did not work? Why didn't it work? Would it ever work? Why or why not? So a lot of why are we doing this? How does this happen? And that application component of rigor is included in all the mathematical practices. So MP4, model with mathematics. Students may apply formulas or equations, use models to draw conclusions, explain why it is good, what is a good model for the problem. The teacher may ask, what are some ways to represent the quantities? Could be M&Ms, could be money, could be a lot of things. What formula might apply in this situation? Mathematical practice 5, use appropriate tools strategically. The student may ask or want to know which tools are appropriate for the task and know when to use the tool and justify the tool selection. Again, calculators are a tool, but sometimes You don't need a calculator for 2 plus 2, but you may need it for a quadratic equation, and when to use that calculator appropriately. The teachers may say, what do you know that is not stated in the problem, and what approach are you considering in trying this first? And the bottom line for all of these mathematical practices is that what we're trying to do is not just see a problem, what's beyond the problem or what's within the problem, and what is it really asking for. And as Lula talked about earlier, rigor is so important in the mathematical practices because it allows you to see what the students know about the actual concept or the skill that they're trying to learn. Attend to precision. The student may ask or calculates accurately and efficiently. They may use proper unit labels with measuring and use appropriate labels in graphing and solving story problems. The teacher may ask what mathematical terms apply in this situation. How did you know your solution was reasonable? What would be a more efficient strategy? Again, we're thinking about what we're doing. We're not just going through the procedural skill and fluency. We're trying to understand and apply. Mathematical practice 7, look for and make use of structure. Students should use properties of operations to make sense of problems. They should recognize how numbers and shapes are organized. Look for patterns and structures in the number system. And again, if you look at the mathematical practices, they build upon one another as well. The teacher may ask, what parts of the problem might you eliminate or simplify? How do you know if something is a pattern? What ideas that we have learned before were useful in solving this problem? Again, building on knowledge you already had. And mathematical practice 8, you want to look for and express regularity in repeated reasoning. Students want to notice if calculations are repeated, if they apply more efficient computation strategies using number patterns, and looks for both general methods and for shortcuts. Teacher may also ask, is this always true, sometimes true, or never true? How would we prove that? What mathematical consistencies do you notice? The standards for mathematical practice rest on processes and proficiencies with established significance in mathematics education. When standards for mathematical practice are connected to content, remember this phrase, remember this, deeper understanding can occur, enabling students to extend them to new situations. And that's what we're saying. Prior knowledge builds you up to the next level of mathematics. So if you remember nothing I said today, just remember that phrase. Deeper understanding can occur, enabling students to extend them to new situations, which are mathematical situations or even life situations. Attention to the standards for mathematical practice shifts the emphasis from just how to get the answer to also learning how to learn. It's a consistency across standards of knowing why and how to learn. You have a question? Oh, I saw your hand. All right. Implications of the standards for mathematical practice on instruction. The standards for mathematical practice are applied across all levels. Not all standards for mathematical practice are appropriate for every lesson. So you don't have to use it for every lesson. Some may only require MP1 and MP2, but you just need to understand them well enough to know which ones apply to which particular problem. Students need opportunities to experience all of the standards for mathematical practice over the course of the unit or the level of study. So at each point when you're working on problems, they should experience those mathematical practices so they will know what they are. All right. Any questions about mathematical practice before the competitive streak comes out? Anybody have any questions about mathematical practice? All right, we will work with standards for mathematical practice.